So osmosis is the movement of water, the diffusion of water across a semi-permeable membrane. That's a textbook definition. And we would say actually that water moves from an area of high solute concentration, I'll just use this bracket symbol by concentration, and it's going to move toward an area of lower solute concentration. Oh, actually, I just pulled it back. Okay, so water moves from an area of low solute concentration toward an area of high solute concentration. Of course, across a selectively permeable membrane. Now, relatively, if we think about something here, if you've got a solution of water and solutes, relatively, if something has less solute, it means it's probably got more solvent, right? So this is, if I say something has low solute, that means that it's relatively high water. Again, relative, not exactly, and we can't, do it that way. And if I say something has a high amount of solute, that means there's less room in it for water. This is relatively a low concentration of water. Does that kind of make sense? So we're still obeying these kind of laws of physics. Things move from a high, right? Systems always will move from a state of high energy to the lowest energy. And you do know that with regard to concentration, and every molecule has some vibrational energy. You know what you call that? Brownian motion, right? Because electrons in bonds are not static, right? They're always moving around. Even if we say something is in a shell or an orbit, that's just a place where you find it most of the time, right? But they're all moving around. So because all the electrons are moving around, every compound has some vibrational Brownian motion energy. Okay? Now collectively, the more of these molecules that we have in a solution, collectively the higher the energy, right? Does that kind of make sense? So if you have more molecules, more Brownian motion, a higher energy. So this high energy, if we say diffusion is from a high concentrated area to a low concentrated area, absolutely. But why? Because it's going from a high energy state to a lower energy state. Systems, the laws of physics say systems have to tend to the state that takes the lowest energy to maintain. Here. So we have that. So this is still obeying those laws here. But because I can't talk about concentration of water, I have to do it by talking about concentration of salt. Okay, with me on that? Now, what are some ways to measure a concentration of a solute? How could you do it? What are some units of concentration of solutes? Volume? No. Molarity, somebody said. What else? Percent? Heard of that? 5% of something is more than 2% of something, right? This always is a source of confusion. When you took chemistry, did your chemistry teachers do a terrible job of explaining the difference between molarity and molality? Right? Have you heard of those two different things? No? So your chemistry teachers probably thought it ain't even worth talking about. Molarity is moles per liter, right? Molality is moles per 1,000 grams. Now, generally speaking, a liter of water weighs 1,000 grams. Because a milliliter of water is that. But the problem is here, is that how you determine molarity, a 1 molar solution of something, does it have 1,000 milliliters of water in it? No. Because some of the volume is being taken up by the solute. The only thing that has 1,000 milliliters of water in it is pure water, right? Anytime you start adding something in it, and you start filling it up to 1,000 milliliters, it's going to have less water. Does that make sense? Okay. Yeah? This, though, always has 1,000 milliliters of water in it, right? Because if we put 1,000 grams of water in something, how much have I put in? 1,000 milliliters. You see the disconnect between these two, though? They're a little bit different. Yeah, one of them has a true amount of solvent in it, and the other one is a true measure of the solution, which is this one. Are they close enough usually? Yeah. Usually they're close enough so we don't worry about it. Okay. But notice that this one will always, a 1 molar solution will always have a higher concentration than a 1 molal solution will have. Because this one will always have something less than 1,000 milliliters of water. This will always have 1,000 milliliters of water. Okay. It's picky, I realize. Okay. And I don't really care, but except for the fact that when you read something, sometimes you'll read molarity, sometimes you'll read molality. Sometimes you'll read something called osmolarity. Sometimes you'll read something called osmolality. Okay. And the difference has to do with how are we measuring the solvent when we make the solution. Are we measuring it by volume, in which case I add, 20 grams of something in a graduated cylinder, fill it up to 1,000 liters with water, now I've got my 1 molar solution. Or do I add 20 grams of something, weigh out 1,000 grams of water, put that in, then I have molal. Are they often the same? They're never exactly the same, but are they often close enough? Yeah, they're often close enough. So I don't care which definition you use, and for molarity or molality, and for purposes